This section will hopefully seem like a review, as we'll be focusing on how to work with the right triangle and use the Sohcahtoa rule to either set up missing sides or solve for a missing angle. In case you haven't seen this symbol before, I just wanted to emphasize the pronunciation and its meaning, because this is something you're going to see a lot throughout the rest of the class. This theta is used to represent an unknown angle, just like we often use x as a variable for something we don't know. Whenever that thing we're missing is an angle, we usually use this variable. It looks like a circle with a horizontal line through it, and it's pronounced theta. This is a Greek letter, and you'll see it a lot for missing angles. Hopefully this will look familiar to you. The format might seem a little bit different, but this is actually the rule for Sohcahtoa. So if you guys learned that in, I expect, in geometry, you should have learned the phrase Sohcahtoa, and this stands for sine is equal to opposite over hypotenuse. And that's what this says right here. It says if you're dealing with the sine function, then sine of theta, the missing angle, is equal to the opposite side over the hypotenuse. So that's what this part refers to. So, and then we have ka for CAH, that's cosine. So cosine of theta is equal to the adjacent side over the hypotenuse. And the last part is the toa, and that's for tangent of theta, being the opposite side of the triangle over the adjacent side of the triangle. So the opposite, adjacent, and hypotenuse, those are all different based on which angle of the triangle you're looking at. For this triangle right here, we're indicating that theta is in this bottom left corner. So when you're defining the sides, opposite is going to be out of the three sides, it's going to be the one side that's not touching your angle. So this one's touching it, and this one's touching it. That means opposite is the one across from it over here. Adjacent, there are two sides that are touching the angle, but one of them is across from a right angle. The one that's across from a right angle is always the hypotenuse. So if there are two sides touching your angle, then the adjacent side is the other one. So make sure you always identify which one's the hypotenuse, and then adjacent will be the other one that's touching your missing angle. But again, all of this is based on where theta was located. If I had moved theta up here, then the hypotenuse would not change. But now from this position, this side would be the opposite, and this side would be the adjacent. So make sure you do understand how those things will flip around based on where your angle is located. Now, I'm not sure that you guys used these other three trig functions, cosecant, secant, and cotangent, but these are actually just the reciprocals of the ones for Sohcahtoa. So you'll start to learn that cosecant and sine are very closely related. So where sine is equal to the opposite side over the hypotenuse, cosecant is hypotenuse over opposite. It's the same two side lengths, it just flips the fraction upside down. So these are basically reciprocals, and that's probably a good thing to write in your notes somewhere, reciprocal functions. And something I do to help keep track of which ones are tied together, if the function has an s in it, then it's paired with a function that has a c in it. Because a lot of people think that secant and cosecant would be paired and sine and cosine would be paired. But for the reciprocal functions, it actually goes the other way around. So s to c, and then the same thing happens the other way around. Cosine starts with a c, but secant starts with an s. So pair an s with a c for the reciprocals, and then pair the c with the s. Same thing though, cosine is adjacent over hypotenuse, so the reciprocal is hypotenuse over adjacent. And then tangent and cotangent are pretty easy to identify the relationship between them. So tangent is opposite over adjacent, but then cotangent is adjacent over opposite. So when you get rules that refer to the reciprocal functions, as long as you know what they're paired with, just flip that fraction upside down. So here's what your first type of examples will look like. They will give you a diagram, and they will indicate which angle we're using for reference. So for this one, theta is up here in the top corner instead of being down here. The location of theta will change your opposite, adjacent, and hypotenuse values, so be careful about that. So when they ask for the 6 trig functions, then they are looking for the sine, cosine, tangent, and then the cosecant, secant, and cotangent. So I've just gone ahead and already filled those in to save a little bit of time here. But we just need to write the fraction for what sine of theta equals, cosine of theta equals, and tangent of theta equals. The first step should be making sure you identify correctly what the labeling of each side is, whether it's the adjacent, opposite, or hypotenuse. So always start with the right angle. The one that is directly across from it, the one side that is not touching the right angle, that's the one that we call the hypotenuse. So in this case, my hypotenuse is going to be that value of 5. Then from theta, there were two sides that were touching the angle. So if my angle is here, two sides touching it, but one of them we just said is the hypotenuse, That means the other one that is touching it is what we call the adjacent. And then the last side label, the one that is directly across from theta, the only side out of the three that is not touching my angle in the top corner here, this one down here is what we call the opposite side. So now that I've labeled my adjacent, opposite, and hypotenuse, I'm just going to be following the rules that I gave you here in terms of writing the fraction. Which number goes on top, which number goes on the bottom. So it's just going to be a matter of plugging in for each of these three functions. I'll focus on the reciprocal one separately in just a moment. So the rule I gave you for sine is opposite over hypotenuse. And since I just labeled my opposite and hypotenuse sides as 3 and 5, I just need to put 3/5. Now, whenever you write your fraction, make sure you check whether it can be simplified or reduced. In this case, 3 and 5 don't have anything in common. And then the second thing to look for is if you have a radical in the denominator, make sure you rationalize this. If this had been a square root of 5 in the bottom, then I would multiply top and bottom by square root of 5 over square root of 5 and then reduce that answer. Go ahead and do whatever other simplifying you can. But I don't have any radicals, so I don't have anything to show for this right now. Next, the cosine rule. From theta, the cosine rule is adjacent over hypotenuse. Well, I labeled those two sides, so adjacent is 4, hypotenuse is 5, so my answer is 4/5. Again, I do not have anything to simplify here, and I do not have a radical to rationalize in the denominator. So adjacent over hypotenuse is 4/5. And then lastly, tangent is opposite over adjacent. So from my angle, the opposite side was 3, and the adjacent side was 4, which means I write 3/4. Still nothing to reduce and nothing to rationalize on that. So now here's the what I actually consider the easier part. If you look back at the rules for the reciprocal ones again, remember I told you that if sine is opposite over hypotenuse, well, cosecant is going to use those same two lengths, hypotenuse and opposite. It's just going to flip which one's on the top and the bottom. So I can actually just go through and say, all right, if sine was 3/5, then cosecant is 5/3. And then again, if you couldn't simplify the first one, you shouldn't be able to simplify this. But something tricky that does often happen, I could have had a radical in the numerator. Now that radical would be in the denominator. So I might have to rationalize this one, even if I didn't rationalize the first one. And then for cosine, the reciprocal is secant. Remember, pair the c with the s with c with s, for which ones are paired. So if this was 4/5, the reciprocal is 5/4. And then for tangent and cotangent, 3/4 becomes 4/3. So again, make sure you guys understand which ones are paired together, which ones are reciprocals of each other. Once you memorize that, this is actually very easy to fill in the other three answers there. So that's all for this example. All they wanted was the 6 trig functions set up. Now later on in this section, we'll learn actually how to use this expression to solve for what the missing angle was. Right now, I don't know if this was 30 degrees or 50 degrees, but later on I'll be able to use this information to get an answer for what theta is. Here's the second type of example you'll be given. They will still be asking us for all the trig functions, but instead of drawing the diagram for us, they're giving us one of the values. So we're going to have to use that to kind of set up our own triangle and then identify what our values are from there. What I would encourage you to do really is to draw your own triangle. It doesn't have to be perfect. Just set up a triangle and put theta in one of the corners of your triangle, and then you have your right angle in another one. Well, remember that the rule for sine is opposite over hypotenuse. So I could actually fill in those two sides. The opposite side from my theta value is going to be 5, and the hypotenuse side is going to be 6. And then since I have two of the sides of a right triangle, I can use Pythagorean Theorem to solve for the missing side. So I could say a squared plus b squared, which is 5 squared, equals c squared. And then we can evaluate some of these numbers because I know that 5 squared is 25, and I know 6 squared is 36. So next you would subtract 25 to the other side. And then that means if you take the square root of this number, you get the square root of 11. So our missing value was not a nice even integer. We have an irrational number instead, but that will happen sometimes. And so this will complicate some of our answers when we have to rationalize the radical denominators. So at this point, now it's just like what we did in example 1. I have the 3 sides of a triangle, and I'm just going to go through and write the sine, cosine, tangent part real quick. Now, the first answer was actually directly given to us. I could get it again by saying opposite of hypotenuse, but they just flat out gave me sine of theta is equal to 5/6. In this example, they were actually just asking for the remaining ones, but just for completeness, I went ahead and wrote this anyways. So for the reciprocal, if I want to do that right away, if I flip those numbers upside down, I would have 6/5 instead. Nothing to simplify, nothing to rationalize, that one's done. Going back to my triangle, the rule for cosine is adjacent over hypotenuse. So my adjacent side is that ugly square root of 11, and my hypotenuse is that 6. But since my radical is on top, I don't need to rationalize that. It just stays as square root of 11 over 6. However, when I flip this one upside down, the problem with 6 over square root of 11 is it has the radical in the denominator. So you multiply top and bottom by that radical, in this case square root of 11. Whenever you have a radical in the denominator of your fraction, multiply top and bottom by that radical. And then simplify this. So on top, 6 times root 11 is 6 root 11. You can't combine those because one number is outside of the radical, one number is inside the radical. But on the bottom, the square root of 11 times the square root of 11 is 11. And then nothing simplifies on the top and the bottom. If this number on the bottom had ended up being a 12, for example, I would have had to recognize that 6 over 12 is 1/2 and reduce those numbers. But in this case, 6 and 11 don't have anything in common, so I leave my answer there as 6 root 11 over 11. Do not put radicals in the bottom of the fraction. And then the rule for tangent is opposite over adjacent. So my opposite side is 5, and my adjacent side is square root of 11. But since I have my radical in the bottom, I need to rationalize this again. So multiply top and bottom by root 11. And instead leave your answer as 5 root 11 over 11. Again, the 5 and the 11 don't have anything in common, so just leave it in that form. But cotangent, when I flip this back around the other way for the reciprocal, look back at the original form. Don't flip this one. Go back to this one. If I flip this upside down, I would have square root of 11 on top of 5. And that's fine to leave as is. This one did not need to be rationalized. So usually you'll notice that the rationalizing should only happen on one side or the other for your reciprocal values. You shouldn't end up having to do it for both of the paired functions. So that's it for this section of notes. We've seen how to write the 6 trig functions based on our Secant rules. The reciprocal ones might be new for you, but it really is as straightforward as just taking the reciprocal of the other 3 functions. Just make sure you guys understand which ones are paired together so that you don't accidentally write the wrong numbers with the wrong functions.